Today we will tackle about mathematical reasoning and mathematical proof. First, what is mathematical reasoning? Mathematical reasoning, or the principle of mathematical reasoning, is a part of mathematics where we determine the truth values of the given statement. Also, mathematical reasoning is a critical skill that enables a student to make use all of mathematical skill. Mathematical reasoners are able to reflect on solution to problem and determine whether or not they make sense. They appreciate the pervasive use of and power of reasoning as a part of mathematics. Here is an example. The sum of two prime numbers is always even. The given statement can either be true or false. Since the sum of two prime numbers can be either an even or an odd number, such statements are mathematically not acceptable for reasoning, as this sentence is ambiguous. Thus, a sentence is only acceptable mathematically when it is either true or false, but not at the same time. Therefore, basic entity required for a mathematical reasoning is a statement. Next, we have the two types of reasoning in maths: the inductive reasoning and the deductive reasoning. What is inductive reasoning? Inductive method of mathematical reasoning, the validity of the statement is checked by a certain set of rules, and then it is generalized. The principle of mathematical induction uses the concept of inductive reasoning. Example: Statement 1. The cost of goods in RS10 and the cost of labor to manufacture the item RS5, the sale price of the item is RS50. From the statement above, it can be said that the item will provide good profit for the store selling it. In short, as inductive reasoning, it is generalized. It is not considered as geometrical proofs. Next is the deductive reasoning. The principle of deductive reasoning is the opposite of the principle of induction. On the contrary to inductive reasoning, in deductive reasoning, we apply the rules of general case to a given statement and make it true particular statement. The principle of mathematical induction uses the concept of deductive reasoning. The below given example will help us to understand the concept of deductive reasoning in math better. Example: the Pythagorean theorem holds true for any right triangle. If a triangle XYZ is a right triangle, it will follow Pythagorean theorem. Next, we have the type of reasoning statement. There are three main types of reasoning statement: the simple statement, compound statement, and the if-then statement. First is the simple statement. A simple statement are those which are direct and do not include any modifier. These statements are more comfortable to solve and does not require much reasoning. An example of a simple statement is the sun rises to the east. In this statement, there is no modifier, and thus it can be simply concluded as true. Next is the compound statement. With the help of a certain connectives, when we club different statements, such statement made up of two or more statements, we known as a compound statement. These connectives can be and or, and more. With the help of such statement, the concept of mathematical deduction can be implemented very easily for better understanding. Consider the following example. Even numbers are divisible by 2. 2 is also an even number. These two statements can be clubbed together as Compound statement. Even numbers are divisible by 2, and 2 is also even number. Another example is a triangle has 3 sides, and the sum of interior angles of a triangle is 180. A triangle has 3 sides, statement number 1, and statement number 2 is the sum of the interior angles of a triangle is 180. These both statements related to triangle are mathematically true. These two statements connected using and. Next is the if-then statement. According to the reasoning, if we encounter an if-then statement, then by proving is a true, B can be provided to be true, or if we prove that B is false, and then A is also false. If we encounter a statement which says A if and only if B, then we can give reasoning for such statement by showing that if A is true, then B is also true. And if B is true, then A is also true. Example, 8 is multiple of 64. And 8 is a factor of 64. Since one of the given statement is true, therefore A or B is true. Here, if then statement, we are concluding that if A is true, therefore B is true. Next is how to deduce mathematical statements. For deducing new statement or for making important deduction from the given statement, 3 techniques are generally used: the negation of the given statement, the contradiction method, and the counter statement. First is the negation of the given statement. In this method, we generate new statement from the old ones by the rejection of the given statement. In other words, we deny the given statement and express it all new one. Consider the following example to understand it better. The sum of the square of 2 natural numbers is positive. Now, if we negate this statement, then the sum of squares of 2 natural numbers is not positive. Here, by using not, we denied the given statement, and now the following can be inferred from the negation of this statement. There exist 2 numbers whose square do not add up to give positive number. This is a false statement, as squares of 2 natural numbers will be positive. Next is the contradiction method. In this method, we assume that the given statement is false and then try to prove the assumption wrong. Example, the derivative of y is equals to 9x squared plus sine x WRTX is 18x plus cosine x. Hence, our assumption is wrong and the statement is a valid statement. For proving the validity of this statement, let us say that the derivative is not equal to 18x plus cosine x. We know that the derivative of x is given by the n times the x to the power n minus 1. Therefore, the derivative of 9x squared is 18x, and the derivative of sine x given by cosine x. Therefore, the derivative of 9x squared plus sine x is equals to 18x plus cosine x. Our assumption is wrong and the statement is a valid statement. Next is the counter statement. Another method for proving validity is to use a counter statement, giving the statement for the example where the given statement is not valid. Example, if x is a prime number, then x is always odd. To show that the given statement is false, we will try to find a counter statement for this. We know that 2 is a prime number. It is divisible only by itself and 1. Also, 2 is a smallest even number. Therefore, we can say that 2 is a prime number which is even. We can say that the statement A is not true for all prime numbers. Therefore, the given statement is not valid. Next is mathematical proof. What is mathematical proof? Mathematical proof shows that the statement to be true using definition, theorems, and postulate. Just with the court case or no assumption can be made in mathematical proof. Every step in mathematical logical sequence must be proven in a direct proof. The statements are used to prove the conclusion is true. We have three types of mathematical proof: the direct proof, proof by contradiction, and proof by induction. What first is proof of direct proof? A direct proof is a way of showing the truth or falsehood of a given statement by straightforward combination of established facts, usually called axioms, existing lemmas and theorems without making or any further assumption. Next is the proof by contradiction. Proof by contradiction is a form of proof that establishes the truth of the validity of a proposition by showing that assuming the proposition to be false leads to a contradiction. Next is the proof by induction. Proof by induction is just like an ordinary proof, in which every step must be justified. It employs a near trick which allows you to prove a statement about an arbitrary number, and by first proving it is true when n is 1 and then assuming it is true for n equals k and showing it is true for n equals k plus 1. Next, the 5 parts of proof. The most common form of explicit proof in geometry is two-column proofs consist of 5 parts: the given proposition, the given, the proposition, the statement column, the reason column, and the diagram. That's the end of my presentation. Thank you for watching. God bless us all and have a good day.